All right, so what I want to do is review with you how to do all the things that we've discussed. And one of the first things we discussed with the electron is wavelength and frequency. So remember that there's two formulas that you need to remember. So the first formula is C equals wavelength times frequency, and energy equals the frequency times H. Okay? You're always given C, which is 3.0 times 10 to the 8th. And you're always given H, so this is C. You're always given H, which is 6.626 times 10 to the negative 34. Okay, so what I want you to do is let's look at this problem. If you can work it, then stop the video, work it, and then come back and see if you worked it correctly based on what I'm doing. So we're looking for two things here. We're looking for energy and we're looking for frequency. What we know is our wavelength. So that means I've got to use this formula. So I know my C is 3 times 10 to the 8th. I know that my wavelength, I don't know V, but I know that my wavelength is 3.6 times 10 to the negative 9th. So remember, when you've got something like this, you divide so that you get your variable by itself. Okay, so when we put this in the calculator, we get 3.0 times 10 to the 8th divided by 3.6 times 10 to the negative 9th. You're going to get, for your frequency, you're going to get 8.3 times 10 to the 16th. All right, so if I know this is V, so if I know V, now I can find H. So, I can find E because see, I know V and I know H. So 8.3 times 10 to the 16th times 6.626 times 10 to the negative 34. So this is going to equal 5.5 times 10 to the negative 17. So what I've got, here is my frequency and here is my energy. Now, here's the key. Remember that frequency is in hertz. Energy is in joules, okay? So that's how you solve those problems. But let's look at a wavelength problem. So you remember your wavelength. Let's take and label. So here's my wave. Okay. So this right here is the crest of the wave. This is the trough. Between here and here, that is the wavelength. All right. If this was over time, how many waves would be my frequency in hertz? Okay. This from here to here is my amplitude. So the reason we talk about wavelength and frequency is because electrons give off certain waves. And if I'm looking at something like this, let's say that my wavelength is like this. So this would mean that I have a long wavelength, but I've got a low frequency and I've got low energy. All right. So wavelength, the longer the wavelength, the less energy it has because it has a lower frequency. If I look at something like this, okay, this has a short wavelength, which means it's got a high frequency and it's got a high energy. Okay, so in a second, when we talk about how the different colors of light and the different things like that, that's going to help to make sense with that. So make sure you know the parts of the wave. Make sure that you know this whole what do you call it? Not analogy, but relationship between wavelength, frequency, and energy, because that's going to help you.